coordinate geometry. This is the second module under this chapter. Part 2, we are going to discuss about section formula here. Let us try to understand what is meant by section formula. We have here 2 points A and B. Coordinates of A are x1, y1, B are x2, y2. On the line joining points A and B, there is a point P whose coordinates are x and y, and this point P divides the line AB in the ratio of m1 colon m2. If this length is m1, this length is m2. Now in such a case, the values of x and y, that is the coordinates of P, can be expressed in terms of x1, y1, x2, y2, m1 and m2, and that is x equal to m1 x2 plus m2 x1 divided by m1 plus m2, y equal to m1 y2 plus m2 y1 divided by m1 plus m2. Now let me state this again. Now the coordinates of the point P, that is xy, that divides the line joining the points A and B in the ratio of m1 and m2 are here m1 x2 plus m2 x1 divided by m1 plus m2 and m1 y2 plus m2 y1 divided by m1 plus m2. Now this is known as section formula. You need to just remember this. We need not understand how we arrived at this. That is out of the scope. Now, if the ratio in which P divides the line AB is k colon 1 instead of m1 colon m2, we can also take it as k colon 1. Let us see how it is. Divide both sides by m2. This becomes m1 by m2 colon m2 by m2, that is 1. So I will take m1 by m2 as k, so k colon 1. So if the ratio in which P divides the line AB is k colon 1, is a small k, then the coordinates of the point P are k x2 plus x1 divided by k plus 1, k y2 plus y1 divided by k plus 1. This is little simpler than the earlier formula. This is also known as section formula. Now, one more scenario. If P, the point P is the midpoint of the line AB, when it is the midpoint, this is A, this is B, P is the midpoint. Now if this is K, this is 1, K is to 1, but it is a midpoint, so this is 1, this is 1. So both are 1, K is also 1. Now if P is the midpoint of line AB and then it divides the AB in the ratio of 1:1, here K is also 1, then the section formula becomes, let us substitute K as 1 in the above formula. So 1 into x2 plus x1 divided by 1 plus 1, 1 into y2 plus y1 divided by 1 plus 1. So coordinates of the point P are now x1 plus x2 divided by 2 and y1 plus y2 divided by 2, and this is only as a special case when P is the midpoint. This is also section formula, but a special case. These are the three things what you need to remember, and all the exercises are based on these three formulas. Now let us get into solving some exercises. First one, find the coordinates of the point which divides the join of -1, 7 and 4, -3 in the ratio of 2 colon 3. So point A is -1, 7, B is 4, -3 and m1 colon m2 is 2 colon 3, m1 equal to m2 equal to 3. Now we need to find out the point P whose coordinates are x and y. Now from the section formula, x equal to m1 x2 plus m2 x1 divided by m1 plus m2. m1 equal to 2 into x2. x2 equal to 4 plus m2 equal to 3 into x1 equal to minus 1 divided by m1 plus m2 is 2 plus 3. So this becomes 8 minus 3 divided by 5. So it is 5 divided by 5 equal to 1. That is x equal to 1. Now y equal to m1 y2 plus m2 y1 divided by m1 plus m2. Now m1 is 2, y2 is minus 3 plus m2 is 3 into y1 is 7 divided by denominator the same, that is 5. So this becomes minus 6 plus 21 divided by 5, that is equal to 15 divided by 5 equal to 3. So y equal to 3. Therefore, the coordinates of point P, that is the coordinates xy, that divides the above line in the ratio of 2:3, that is equal to 1,3, or I can write as P 1,3. Exercise number 2. Find the coordinates of the points of trisection of the line segment joining 4, 1 and minus 2, minus 3. Let's take this as A, this as B. Now you have a line AB. This is A, this is B. This is 4, minus 1. This is minus 2, minus 3. You have to find the points of trisection. Trisection means line AB has to be divided into 3 equal parts. These points are P and Q. If this is 1, this is also 1, this is also 1. Now let us first find point P. Once you find point P, then Q is the midpoint of P and B. Let us first find the point B. Now this ratio m1 equal to 1, that is from here to here, AP. Now PB is 2 units, so m2 equal to 2. Therefore now x coordinate of point P equal to m1 x2 plus m2 x1 divided by m1 plus m2. Now m1 is 1 into x2. This is x2 y2. So x2 is minus 2 plus m2 is 2 into x1. x1 is 4 divided by 1 plus 2. So this becomes minus 2 plus 8 divided by 3. So 6 divided by 3 equal to 2. X coordinate is 2. Let us find out y. Y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2. Denominator is 3, does not change. m1 is 1 into y2, 1 into minus 3 plus m2 is 2 into y1 is into minus 1. So this is minus 3 minus 2 divided by 3 is minus 5 divided by 3 equal to minus 5 by 3. So coordinates of point P are 2 and minus 5 by 3. So Q is the midpoint of P and B. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So again we will calculate now the coordinates of point Q. So x coordinate equal to x1 plus x2. x1 is 2, x2 is minus 2. So 2 minus 2 divided by 2. So this is 0 divided by 2 equal to 0. Now y1 plus y2 minus 5 by 3 plus minus 3 divided by 2. So this becomes minus 5 by 3 minus 3 divided by 2. Now with the LCM, 3 minus 5 minus 9 divided by 2, this becomes minus 14 divided by 6. You have to multiply 2 and 3, that is equal to minus 7 divided by 3. So the coordinates of point Q are 0, minus 7 by 3. Find the ratio in which the line segment joining points minus 3 and 10, 6 and minus 8 is divided by this point. So let us take point A as minus 3, 10 and B is 6, minus 8. Let us take this point as P, which divides these two, the line joining these 2 points, minus 1, 6. Now as per section formula, the coordinates of this point P, the x coordinate, that is equal to k x2 plus x1 divided by k plus 1. This is the formula. Now let us substitute. We know x, that is minus 1. Minus 1 equal to, we don't know k, we have to find out, x2. This is x2. x2 equal to 6, k into 6 plus x1. x1 is minus 3 divided by k plus 1. Let us multiply k plus 1 with minus 1. So minus k minus 1 equal to 6k minus 3. I will take 3 to the other side. So minus 3 will become plus 3 and minus 1. So it will be 2. Here it is 6k plus k, it is 7k. Therefore k equal to 2 by 7. So point P divides the line in the ratio of k colon 1. So k is 2 by 7 colon 1. Now let us multiply both sides by 7. 7 cancels. So it divides in the ratio of 2 colon 7. This is the ratio in which the point P minus 1, 6 divides the line joining the points minus 3, 10 and 6, minus 8. 2:7. Find the ratio in which the line segment joining A 1 minus 5 and B minus 4, 5 is divided by the x-axis. Also find the coordinates of the point of division. Now let us draw the graph. So point A is 1 minus 5, 1 minus 5. Let us approximately mark here. This is point A, 1, minus 5. point B is minus 4 comma 5. Minus 4 comma 5. Somewhere here, this is point B, minus 4 comma 5. So this is the line joining these 2 points. It cuts the x-axis in this point. So this is x comma 0. Y coordinate is 0 because this point is on the x-axis. Let us take this as x2, y2 and this as x1, y1. Now from the section formula, we know the y coordinate y equal to k y2 plus y1 divided by k plus 1. Now y coordinate here is 0. So 0 equal to k into y2. y2 here is 5 plus y1. y1 is minus 5 divided by k plus 1. If I cross multiply, this becomes 0. Therefore, this is k5 or 5k. 5k minus 5 equal to 0. Therefore, 5k equal to 5. Therefore, k equal to 1. The point P divides the line AB in the ratio of k is to 1, but k is also 1. So this is also 1. So it divides in the ratio of 1 is to 1. So P is the midpoint of A and B. Therefore, x equal to, it is a midpoint, that is 1 plus minus 4 divided by 2, that is minus 3 by 2. That is the x coordinate. Y coordinate is 0. If 1, 2, 4, y, x, 6 and 3, 5 are the vertices of a parallelogram taken in order, find the values of x and y. Let us draw a parallelogram. This is a parallelogram and this is A 1, 2, B is 4, y, C is x, 6, D is 3, 5. Let us draw the diagonals. This point, let us say O, that is x, y. We know in parallelogram that diagonals bisect each other, that is this is equal to this base and this here AO equal to CO. Since diagonals bisect each other, point O is the midpoint of AC as well as BD. Now x coordinate of O, x coordinate of O equal to x1 plus x2 by 2, that is 3 plus 4 divided by 2 because it is the midpoint, and also it is 1 plus x divided by 2, that is equal to 1 plus x divided by 2. This is the x coordinate of O. From this, 3 plus 4 is equal to 1 plus x. Therefore, x equal to 7 minus 1, x equal to 6. In a similar way, y coordinate of O is 5 plus y divided by 2, that is 5 plus y divided by 2, that is also equal to 2 plus 6 divided by 2, because O is the midpoint of both the lines. Therefore 5 plus y equal to 2 plus 6. 2 plus 6, 8 minus 5. Therefore y equal to 3. So these are the two answers, the missing values, x equal to 6 and y equal to 3. Find the coordinates of point A where AB is the diameter of a circle. Let us draw a circle first. AB is the diameter of the circle. Sorry, this is the midpoint. This is A, this is B. Whose center is 2, minus 3. 2, and B is 1, 4. You have to find the coordinates of point A. So let us take this as S, Y. AB is the diameter, O is the center, so AO equal to OB. O is the midpoint of A and B, therefore x coordinate 2, that is the x coordinate of the midpoint, is equal to x1 plus x2, that is x plus 1 divided by 2. 4 equal to x plus 1, therefore x equal to 3. Y coordinate of midpoint O, that is minus 3, equal to y1 plus y2 by 2. Y plus 4 divided by 2, multiplying minus 3 with 2, minus 6 equal to y plus 4, therefore y equal to minus 10. So the coordinates of point A are 3, minus 10. Next exercise. If A and B are 2 points, minus 2, minus 2 and 2, minus 4 respectively, find the coordinates of point P such that AP equal to 3 by 7 AB and P lies on the line segment AB. Let us first draw AB. This is the line segment AB. A is minus 2, minus 2 and B is 2, minus 4. Find the coordinates of P. P lies on segment AB. Now such that AP. So let us mark the point P. This is the point P whose coordinates we need to find out. AP equal to 3 by 7 AB. This is AP. This is AB. AP equal to 3 by 7 AP. That means if this is 3 parts, this is 7 parts. The entire thing is 7 parts. If this is 3 parts, that is AP, then PB equal to, this is 4 parts. So now we have M1 equal to 3 and M2 equal to 4, and we have here x1, y1, x2, y2. We have to find out coordinates of point P, x and y. Now x equal to M1 x2 plus M2 x1 divided by M1 plus M2. M1 is 3, x2 is this point, that is 2 into 2 plus M2 is 4 into x1 is minus 2 divided by m1 plus m2, that is 7. This is 6 minus 8 divided by 7, that is equal to minus 2 divided by 7. That is the x coordinate. Now y coordinate equal to m1 y2 plus m2 y1 divided by m1 plus m2. m1 is 3, y2 is minus 4 plus, this is minus 4, m2 is 4, y1 is minus 2, 7. This is minus 12 minus 8 divided by 7 is minus 20 divided by 7. So the coordinates of point P are minus 2 by 7, minus 20 by 7. When you have this kind of problems where one segment is given in terms of the total length, you need to first find out the ratios m1 and m2. Find the coordinates of the point which divides the line segment joining A minus 2, 2 and B 2, 8 into 4 equal parts. This is the line A, B. A is minus 2, 2. B is 2, 8. Find the coordinates of the points which divide the line segment into 4 equal parts. So first we have to find out the midpoint. Then again you have to find out the midpoint of both the sections. First midpoint of AB, this point B, P. Then we have to find out the midpoint of AP and PB. Let us take this as Q and R. Now coordinates of point P, x, y equal to x1 plus x2 minus 2 plus 2 divided by 2, y1 plus y2 2 plus 8 divided by 2. This is equal to 0, 10 divided by 2 is 5. So this point is 0, 5. P. Now Q. Coordinates of point Q, that is equal to, now this is x1, y1 and coordinates of P are x2, y2. So minus 2 plus 0, divided by 2, 2 plus 5 divided by 2, that is equal to minus 2 divided by 1, minus 1, 7 divided by 2. Coordinates of point R. This is x1, y1, this is x2, y2. 0 plus 2 divided by 2, 5 plus 8 divided by 2 equal to 1, 30 by 2. So these are the 3 points. These 3 points divide AB into 4 equal parts. In such case, we need to first find out the midpoint of the line and then the midpoint of each of the segments. This is the last exercise. With that, we are done with the section formula.